The next algorithm is random forest algorithm. So what is random forest algorithm? It is also comes under the category of supervised learning algorithm. It can handle both regression and classification process. So how it's going to handle both regression and classification? We know that the random forest or supervised learning machine model, where the data sets are labeled, target variables are used. The random forest can be used for solving any regression, that is called numeric target variable, and classification, which is nothing but categorical target variable problems. So these two, numeric and also the categorical target variables, both will be handled by this random forest. So we all can also call this random forest as and one of the ensemble method, meaning is nothing but the ensemble process which combines the predictions from all the other models. So each of the smaller models in the random forest or ensemble is a decision tree. What we mean is here whatever the small models we are going to use it, we take all the models output, we combine all this output together and we start working on it to predict the correct output. That process is called as ensemble process. This is the simplest meaning. So how the random forest work? So first, before going in depth into this random forest, we see that what is this ensemble process technique or ensemble learning technique. Ensemble is simply, it means that combining a multiple models together. It's a collection of different models which is used for predicting rather as an individual models. We are going to take a multiple models together for the consideration. That process is called as ensemble process. So there are two different types of methods here comes under the ensemble process. One is going to be a bagging, another one is going to be boosting. What is bagging? Bagging is it, which uses a replacement to build a distinct training subset from the sample training data, and majority voting determines the final result. So what it does it starts working on the data sets. What we are going to start training the data sets which has been given as an input. As it goes for training, when the process goes on, it finds that which is giving the majority vote. Majority is who is opting it. That majority vote will act as a final result. For example, there are many what we call it as a we go for example is fruits as an so many people will like fruits. Will somebody will like banana, somebody will like apple, somebody will like custard, somebody will be liking orange. There are different peoples are together. So what the people will do it, so we have kept in a basket the apples. So people, there are many people are sitting around. For take for 5 or 6 people, so they start going and taking the fruits which is available in the basket. So after they take the fruits, we find what the fruit they are holding on their hand. So we found that majority people are taking a banana. And for example, we have 10 people means 5 people would have taken banana, 3 people would have taken apple, and 2 of them would have taken an orange. So among this 10 peoples, we find that who is having the fruit called banana, who is majority fruit is available in what we call it as how many people are you mean selecting banana. When we counted, we found that 5 people are taking banana, and next least is going to be the apple, and the next least is going to be orange. So from that we found that majority are banana. So from that's a way we go for bagging, how the bagging process carried out. This is how we go for voting for the majority what Wednesday. So this is we call it as a bagging is a parallel processing. Parallel process. At a time, people are going to take that fruits. So we are not giving one by one. We are providing it to go and take the fruits. So parallelly, the people are going and picking up the favorite fruits. So this is how this is called bagging process. Bagging process is a parallel process. Well, next we'll go to the boosting process. Boosting is a sequential model. It transforms poor learners to make us strong learners. So sequential is one by one. So I give it. So I am teaching it. I am teaching to the people. So in the class there are poor people. I mean, average people will be there. Poor studying people, average students will be there, and clever students will be there. So we are delivering the content. So if I give an extra coaching to the poor people, I mean poor level students and average level students, what will happen? I'm making that poor learners and the average learners to become a clever learners, almost reaching that clever learners target. So that is called boosting. So how much energy I'm giving or how much inputs I'm giving to make the students to learn better so that they get the pass mark. This is one of the example. For that, we'll be using a new process called AdaBoost and XGBoost. How the random forest works. So next is the bootstrapping this process, which is the main process I'll be using for working under the random forest. So random forest start by creating a multiple decision tree. So I told that it never works with a single thing. It takes the multiple data because it is an ensembling process. It is going to do process. It is going to do it. So each tree is built using a subset of training data. So what will happen? I'll take a simple decision tree. I'll combine all those decision tree together and I'll create an ensemble. I'll create a multiple data sets and I start predicting it and I start voting it, which gives a majority thing. Then means depending on the voting, I can say this comes under this classification. And the regression process also I can do with the random process. In that, I'll be going for finding out how much averaging process I'm going to do it on the result. That is gives a where I'm using my random forest algorithm as a regression process. This is how we go for it here. Taking the simple decision and combining all the decision tree together, forming a result. So that is the meaning of this sentence. Each tree is built using a subset of training data selected through the process called bootstrapping. Bootstrapping involves randomly selecting an n observation, that is called rows, and training data from the training data set with a replacement. This means some observation may be selected multiple times while the others may not be selected for all. So multiple time means with a replacement means what? So I mean there are group of people are there. So I'm going to, so there are a complete 10 or 20 people are there in the group. I can able to classify this group depending on how much, so some people, so depending upon their likes, depending, it's the same fruit examples we can take it. Somebody will be saying that I like banana, so that people will be grouped together. Somebody will say I like fruit. Somebody will be saying I like orange. Like that, I'll group the people. Somebody will be in that category also. Somebody will be liking both banana and fruit. They can also combine in the banana group and they give the answer. And you can start training the data set. Similarly, the people can also like the apple. They can go and stand there and they can give out their answer. You can train the data set like that. Similarly, apple with orange, orange with banana, like that. So you can replace some of the members or the persons to stand in that other group, and they can. You can start evaluating it and you can predict it. This is what we call it as sharing of how the people are sharing the group and giving the answer. This is what we call it as with the replacement process. Example, you can see the same fruit alignment I have given. So this is one of the example. So the class A, class B, class C, we have two classes. I'm going to classify it. One is going to be apple, another one is going to be banana. There are a group of in a basket. We have a group of fruits are available. Different category of fruits are available. So the people are going to select what the fruit they like it. According to that, the voting process has been done, and we are going to find it out what actually the majority votes gives for what fruit. So we found here, according to this example, majority is giving an what apple they have selected, and we conclude that this is the result. That voting gives a result is what apple. So this is how we go for explaining how the random forest works. So bootstrapping sampling means random forest builds a tree, multiple trees by randomly sampling the training data with a replacement. Same process I told. So we can go for replacing one from so among the different groups. This creates a different training sets for each tree. Feature randomness is nothing but each node of a decision tree, a random subset of feature is considered for splitting and further increasing the diversity among the trees. Average prediction is nothing but here only the averaging, what we call it as a regression process, where I can make my random forest work as a regression. Each tree in the random the forest provides a prediction, and final prediction for regression is the average of all the individual predictions. We are going to take an average. After vote, if I go for a voting process, it comes under classification. If I'm going to take an average of all the results I can, if I'm going to predict the result, that comes under the category of a regression process. I think you would have understood. And now we'll see what are the benefits of random forest. Reduced overfitting. Why I go for random forest? So whatever the problems we face in the previous algorithm, so that overfitting or underfitting bias, I mean, where because of bias and variance variations, what causes it? There are two factors. What we call it as we discussed about overfitting and underfitting. So in order to overcome all those problems, we go for this random forest algorithms where it reduces the overfitting. By averaging predictions from multiple trees, the random forest reduces the risk of overfitting, especially when dealing with the complex data sets. Handles the high dimensionality, very large data sets it can able to handle with many features. Non-parametric means does not fall under the category of parametric method, meaning it does not make an assumption about the underlying data distribution. Feature importance is it provides a measure of features. Feature importance is it goes for different feature classification, indicating which features is most influentially making the prediction. Robustness is ensemble approach makes a model more robust to noise and outliers. This is the biggest advantage of using a random forest. So this is about why we go for random forest, what process we are doing it, what is bagging, what is bootstrapping, what is ensembling. All these things we have studied here. I think you would have understood what is random forest algorithm. Thank you.